Hello students. Today we are going to see these three content, that is fundamentals of computing, identification of computational problems and algorithms, right? So this is the basics for learning a programming language. So before learning a programming language, you should know what is computing and what is the problem that is occurring during identification of computation, and what how to solve that problem, right? So these are the basic needs, and we will cover these three topics in this session. So the first one representation is fundamentals of computing. So computing is the foundation of modern technology. So it is represented as the foundation, and it impacts almost every aspect of our life. The fundamentals of computing covers core concepts including hardware, software, data representation, algorithm, and problem solving techniques. So this fundamental includes both hardware and software, as well as how we are representing the data and what algorithm we are using for it, and how we are solving the problem. So now we will see each and every topics which are coming under fundamentals of computing. So the first topic is introduction to computing. So, computing refers to the use of computers and software to process information. It involves various aspects, such as these are the aspects wherever the computing is used. First aspect is computer science, where we are using the computing as theoretically as well as algorithm way of representation. Next is in information technology. There too, we can represent the computing as theoretical and practical application. And in computer engineering for hardware design, we are using this computing. And for software development also, we are for developing programming and application, we are using this computing, right? So these are the areas where computing plays a major role. So next comes computer hardware, right? So as I said earlier, hardware and software both are coming under this computing. First, we will see computer hardware. So computer consists of physical components that perform computing tasks. So the key hardware components are given here, right? So if you see a computer, there will be a CPU and there will be a monitor to display, right? Right, and this two will be connected, and that the socket from here, the power cable from CPU will be connected to the socket, as well as the power cable from a monitor is also connected to the socket, right? So this is represented as central processing unit, which is the brain of computer that process instruction, right? So CPU can be also referenced as processor, right? And then within that itself, we are having the memory card, right? So motherboard, the processor can be either it is an Intel process or AMD process, right? So based on the processor, the CPU is designed. So next is memory. So the memory is used for there are two categories of memory, that is primary memory and secondary memory. So primary memory is used for execution purpose as well as for loading the operating system, and the secondary memory is used for storage purpose, right? So that is what represented as memory. We are having two types of memory, primary and secondary. So, RAM is represented as random access memory, which is represented as primary memory, that is used to temporarily store the data for quick access, right? So, whenever you have switched on the CPU, that is central processing unit, from the storage, the operating system will be loaded to the memory, right? So from the storage, the operating system will be loaded to the memory. So that memory is represented as RAM. After you shut down the system, once again, it will not be available in this primary memory, right? So next, long-term storage devices that are represented as hard disk as well as SSD to hold long-term data. That is the permanent data we can so volatile. So RAM is volatile and this storage devices are non-volatile. The meaning is volatile means once you have switched off the system, the content in the memory will be vanished. That is known as volatile, and this hard disk is non-volatile. Even though you have switched off the system, it will be available in the hard disk, right? So that's all about the difference between primary memory and secondary memory. One of the example of primary memory is RAM, and example of secondary memory is HDD and SSD. So next we will move on to the input devices, right? So for giving the input to the monitor, we need some input devices like keyboard as well as mouse, right? So these are the content we are connecting to the system such that whatever you are typing in this will be displayed in the monitor, right? So that is known as input devices. So there are different input devices available. Here they have given only few of them: keyboard, mouse, scanner and microphone. So this is to get the sound input, and this is to scan the document, and mouse is to for clicking the object, and keyboard to enter the text from the keyboard to the monitor, right? So this is how the input devices are organized. Next, output devices. Here we are using monitor, print and speakers. Speakers to give the sound as output, printer, printed document, and monitor to display the content whatever you are typing from the input devices, right? So that is known as monitor. So that's all about computer hardware. We are having a CPU, memory unit, and then the input output devices. Next, we are going for software and operating systems, right? So we have completed hardware. Next, we are moving to software and operating system. So software enables computer to perform task, and it includes, so what are the softwares that are available apart from operating system? We are having system software. Operating system is also one of the system software, application software and programming software, right? So these are the softwares that are available. So first we will see what is system software. So operating, as I told you earlier, when you switch on the system, the operating system will be booted booted and loaded to your main memory, that is primary memory, right? So since it is a software, it is booted from that um, hard disk to the main memory. So we are having different operating systems. Normally, you used to work with Windows operating system. We are having Mac OS as well as Linux also, right? So Linux, some of the example Ubuntu, Debian, CentOS, these are the operating systems that are available, right? Right. So these are the operate. Apart from this operating system, there are other system softwares like interpreter, compiler, loader, linker, right? So like this, we are having different system softwares which are available. Interpreter is nothing but it will convert the high level language to the machine language line by line, right? So that is what it is interpreter. Compiler is also a intermediate system software which will convert high level language to bytecode first, and once again you have to execute the bytecode in the second phase. And loader is to load the binary files as well, binary packages as well as the operating system from one place to another place. And linker is to link to the library content. The program will be linked to the library packages using this linker. So next comes application software. We are having different application softwares that are available. um, Programs such as web browser, word processor, games, etc. Right. So these are some of the application software that are available, which is used for a specific application. So you can also specify MS Office, which is used word is used for typing, as well as PowerPoint for presentation. Like, we are using a specific application software for a specific purpose, right? So next comes programming software, tools used to write code. So we are having so much of editors, right? So language editors, Visual Studio, VS, right, as well as Sublime Test, right? So like that, we are having so many number of editors. Write the code in that, so it will highlight the syntax and give suggestions of code to be written in the editors. As well as we are also having compilers and text editors for that. So next we will see data representation. So hardware and software is over. Next is data representation. So here we have to represent the data to the computer at any form, right? So so the computer can understand only ones and zeros. So the first one is number system, where the binary base 2 is represented. For example, if you want to represent the decimal 5, we can represent 5 in the binary notation of 2 twos are 4, remainder 1, 2 ones are 2, remainder 0. So the binary representation of 5 is 101, right? So this is what binary, which is base 2 representation. And next is decimal representation. So here 5 is a decimal representation, and hexadecimal representation. So if you, so this is what 5 is. If you multiply with, so this one will be 16 power 0, 16 power 1, and then so this, it is hexadecimal, right? And then 16 power 2, right? So the value will be 16 power 0 is 1 plus 0 plus 16 power 2, 36, 9, 6, 1, 6. Actually, this is wrong. So how we are representing the values of decimal to hexadecimal is base 16. So after 9, 10 will be represented as A, and 11 will be represented as B. Like that it goes off, right? Up to F we can represent the values. So 5, decimal 5 will be represented as decimal 5 itself, right? So after 9 only the values will change. So 10 will be represented as capital A, 11 will be represented as capital B, right? So just I remove all the content. Okay, right? So hexadecimal, we are representing the decimal 5 as 5. And if the decimal value is 10, the hexadecimal value will be A, right? So that is how we are representing hexadecimal. Next is character encoding. We are having ASCII encoding as well as Unicode encoding. So you can specify ASCII encoding as a subset of Unicode encoding. That means ASCII is a part of Unicode encoding, and ASCII can be, so original ASCII is represented using 8 bit, sorry, 7 bits, and then now what ASCII value we are using is of 8 bits, right? So 8 bits means totally you can represent 2 power 8 characters using this ASCII encode. And then Unicode, we are representing more number of values greater than 2 power 8. Next we will see data types. So what are the data types that are available for representing the data? It integer. So integer can be both positive or negative values with a whole number. For example, 2 is an integer, minus 2 is also an integer. Next, floating point, it will have exponential, sorry, it will have both imaginary part and real part. So that is what floating point. So for example, if you represent a 2.3 decimal value, right? So this is represented as a floating point value, right? And then Boolean true or false and string are represented as characters, right? So a sequence of characters, right? So if you represent welcome, that welcome will be represented within double quotes. So these are the data types that are used to represent the data in the programming language. Algorithm and problem solving. Algorithms are step-by-step procedure for solving problems, and these are the important concepts of algorithm. First, algorithm efficiency. It is measured using big O notation, right? So worst case representation is represented as big O notation. So hence the efficiency is measured using big O notation. Next is basic algorithms that are used in problem solving, bubble sort, quick sort, and searching binary search, right? So bubble sort, the worst case big O notation will be big O of n squared. Similarly, binary search, log n, big O of log n, and like that it goes off, right? So next is problem solving techniques, divide and conquer, recursion, iteration, right? So these are the problem solving techniques that are available. So divide and conquer. First, the given problem is divided into so many sub problems, and after finding the solution for the sub problems, once again it is merged to for it is conquered to get the final solution, right? So this is known as divide and conquer. Recursion, a set of instruction will be keep on executing with the values what we are passing as argument, and then you will get the final output, right? So that is known as recursion. So this it should have an end point value, otherwise this will lead to infinite looping, right? So recursion, a particular module will be executed n number of times to get the output, and it should definitely have a end value. Otherwise, it will be in a infinite loop. And iteration, it's also similar, but here we will give the condition. If the condition is true, then it will go inside the loop. Otherwise, if it is false, it will come outside the loop and print the output, right? So until the condition is true, the set of statements will get executed n number of times. So if the condition is for n, then n number of times the statements which is inside the loop will be executed, right? So that is the difference between recursion and iteration. A module calls itself is known as recursion, or function calls itself is known as recursion. But for iteration, we will set the condition such that until the condition satisfies, the statements inside the loop will be executed. If it is not satisfying the condition, it will come outside the loop. So next is programming basics. Programming allows computer to execute instructions. So these are the basics of programming languages. So in this following lectures, we are going to see about Python, right? And then we are also having other languages like Java, C++, and JavaScript. So here, as I said earlier, system software or programming software, Python uses interpreter, Java, C++, and JavaScript uses compiler, right? So Python uses interpreter, Java and C++ uses compiler. Okay. So next is control statements. We are having different control statements that are control structures, not statements, control structures. So loops, conditional, the conditional statements are nothing but branching statement, loops, iteration, as we have seen here, right? So iteration, and functions are nothing but modules, right? So this module you can call n number of times whenever you need that particular module. And excuse me. So conditional statement, if the condition is true, it will execute some set of statement. If it is false, it will execute another set of statement, right? So that is what conditional statements. And loops, as I said earlier, similar to iteration, until the condition uh, satisfies, until the condition is valid, it will keep on executing the statements inside the condition. So next, computer networks and internet network enabling communication between devices. So we are having different. So computing is used for this networks and internet also. So types of networks: local area, wide area, and metropolitan area network. Similarly, we are using internet basics like for protocols, HTTP for web browsing, and TCP/IP for for supporting the application layer protocols, connection oriented TCP/IP connectionless, and DNS domain names system, which will map between the IP address and then the domain names. Next is cyber security, encryption, firewalls, authentication, right? Next, database and data management. Database store and manage information efficiently. So, relational databases, SQL based, MySQL, PostgreSQL, right? So, these are structure based databases, right? SQL is nothing but structured query language. For databases, also, we required computing. Networks, also, we required computing, right? So, next, we are also having NoSQL databases, which is based on key value pairs, MongoDB and Firebase, and data structures, arrays, linked lists, stacks, and queues. Next comes artificial intelligence and emerging technologies. So this is also based on computing, how it works. So computing continues to evolve in AI, blockchain, and cloud computing, right? So, under artificial intelligence and emerging techniques, artificial intelligence, machine learning, cloud computing for emerging techniques, and cyber security and ethical consideration is also available. So, that's all about fundamentals of computing, and this provides the basis for understanding how computers function and how they solve problems. Right. So, next we will move on to the second topic, which is identification of computational problems. How to identify the computational problem. So, it is a crucial step in problem solving using computers. A computational problem is a problem that can be solved algorithmically using finite sequence of well-defined steps. These problems are typically found in fields such as computer science, data science, artificial intelligence, and engineering. So, first we will see the characteristics of computational problems. So, to determine if a problem is computational, it should have the following characteristics if it is a computational problem. First, computational problem should be a well defined input. It should have well defined input. The problem should take structured and clear input data. And second, it should define the output clearly. What should be the output, and it should be a measurable one. And third one, algorithmic solution. It provides a step-by-step procedure that should that exists to solve the problem. And next is feasibility. The solution should be computable with a reasonable amount of time and resources, right? So that is known as feasibility. So next is types of computational problems. So we have seen the characteristics, well-defined, defined output, algorithmic solution, and feasibility. Next, we will move on to the types of computational problems. So the computational problems can be categorized based on their nature and complexity. First one is decision problems. So decision problems takes only two answers, either it is yes or no. Example is a given number is prime. It has to test the primality, and if it pass the primality test, it should print as prime. Otherwise, it should print not prime. Right. So that is the decision problem. And second comes optimization problem. These problems seek the best solution among many possibilities. That means there are so many number of solutions, S1, S2, S3, and you have to identify which is the optimized solution for the given problem. That is known as optimization problem. So find the shortest route connecting multiple city is a optimization problem. Similarly, traveling salesman to find the shortest path that visits each city once is also a optimization problem. Next is search problems. So this problem involve finding a solution from a set of possible solution. Example, find a specific word in a dictionary. Computational example, binary search algorithm, which will efficiently search a sorted data, right? So, for example, if you want to search for a content in the dictionary based on the index, you will just go through the index and select the corresponding page and you will go through that. Similarly, binary search algorithm will divide the content based on if it is less, it will keep it in the left hand side, and if it is greater based on the root element, it will keep it in the right hand side. Like that it will generate. Next is classification problem. This involves categorizing data into predefined classes. Example, identify whether an email is a spam or not. So that is known as classification problem. We are classifying the given data set whether this data is spam or not. And computational example for this is machine learning classification models, decision trees, neural networks. So next steps in identifying a computational problem. First step, we will define the problem clearly. First, we have to define the problem statement. Next, what are the inputs that are given to that problem statement and how the output should occur. All this information should be provided. And the constraint for that problem should also be clearly given: time, space, and accuracy. So, step two, analyze whether it can be computed, right? So, is there any known algorithm to solve it? Can it be expressed mathematically? Does it require approximation, right? So, like that, you have to identify whether it is computationally solvable. Next, determine the complexity. So the complexity determination based on these three categories, for either it is a trackable problem, or it is an intractable problem, or it is a undecidable problem. So if it is trackable, it will comes under P class and can be solved efficiently in polynomial time. And if it is intractable problem, it is hard to solve but easy to verify. Undecidable problem, no algorithm can solve them. Next step, select an appropriate approach. First, we have to select the exact algorithm which provide precise answer. Example, sorting algorithm. If you want to sort the given set of data, then we can go for the sorting algorithm. Next is heuristic methods, approximate solution for complex problem. Example, genetic algorithms. So, next, appropriate approach, machine learning models handle problem with uncertain patterns. Example, image recognition, which will have rigid edges to identify. So examples of computational problems are given here, and the type of the problem and example algorithm is also given here. Finding the shortest path in the city. The type of the problem is optimization. Already we have seen that. And example algorithm is Dijistra's algorithm. Check that means optimization. So many solutions will be there, but we are selecting the optimized solution. Next is checking if a word exists in the dictionary, search type, and then the example is binary search. Next is sorting a list of numbers. The type is sorting, and we are representing the algorithm as merge sort and quick sort. Next, identifying handwritten digits, classification, neural networks. And then predicting stock prices, prediction type algorithm, and regression model is used for this prediction. Encrypting a message, cryptography, RSA algorithm, which is a public key algorithm, which is used for it. So next we will see the real world applications. Computational problem identification is essential in artificial intelligence, data science, cyber security, and software development. So that's all about the identifying how to identify computational problem and how to categorize it based on the types and what type of algorithms are used for it. Next, we will move on to the introduction to algorithm. So first we will see what is an algorithm. Then we will move on to the characteristics of it. So an algorithm is a step-by-step procedure or set of rules to solve a specific problem or perform a computation. Right. So you just remember the statement step-by-step procedure or set of rules to solve a specific problem. Algorithms are fundamental to computer science and are used in various fields such as artificial intelligence, data science, cryptography, and more. So, the first one is characteristics of a good algorithm. A well designed algorithm should have the following properties: well defined input, well defined output, definiteness, finiteness, effectiveness. So, well-defined input and output, already we have seen. The algorithm must take zero or more well-defined input and it should produce at least one output. Definiteness, each step should be clear and unambiguous. And finiteness, it should terminate after finite number of steps. It should not be infinite, right? So that is known as finiteness. And effectiveness, each step should be simple and executable in a reasonable time. Next, types of algorithms. Algorithms can be classified based on their approach and usage. First one is brute force algorithm, solve problems by checking all possible solutions. So this is similar to a trial and error method. So example for brute force algorithm, linear search, checking each element in a list until the target is found. Next is divide and conquer algorithm. So break a problem into smaller subproblems, solve them recursively, and then combine the result. Right. So that is an merge shot and quick shot. Next comes greedy algorithm. Make the best choice at each step with the hope of finding the global optimum. Right. So example Dijistra's algorithm. Next is dynamic programming. Break problems into overlapping subproblems and store their solution to avoid redundancy. Example Fibonacci sequence and knapsack problem, right? So these are represented as dynamic programming. Break problems into overlapping subproblems and store their solution to avoid redundancy. Next is backtracking. Try all possible solutions and backtrack if a solution fails. Example n queen problem, Sudoku solver, right? So you will keep on going with the rules and conditions given, and if it fails, you have to backtrack and start with the previous one. Next is graph algorithm, which is used for graph related problems such as shortest path and connectivity. Example, breadth first search, depth first search, Dijistra's algorithm. Next, we will measure the complexity of algorithm using big O notation. So algorithm performance is measured using time complexity and space complexity. The efficiency of the algorithm depends on these two factors, that is the time complexity and space complexity. So for time complexity, we are representing the big O notation. Big O of 1 represent constant time. Example, accessing an array element. Big O of log n represent logarithmic time. Example, binary search. Big O of n, linear time. Example, linear search. Big O of n log n, linear arithmetic time. That is example, merge sort. And big O of n squared, quadratic time. Example, bubble sort. And big O of 2 power n, exponential time. Example, recursive Fibonacci. Next, we will see the commonly used algorithm. First is searching algorithm. First type linear search, big O of n, and binary search, big O of log n. So compared to big O of n, big O of log n is having less time complexity. It is efficient. The time complexity is efficient for binary search. Next comes sorting algorithms. Bubble sort, big O of n squared, merge sort, big O of n log n, quick sort, big O of n log n, and graph algorithm. But first search, V represents the vertex and E represents the edges. So big O of V plus E. Depth first is also representing the same big O of V plus E. And Dijistra's algorithm, big O of V squared or big O of E log V with priority queue. So the applications of algorithms. Algorithms are used in the field of data science for machine learning models, cyber security, for encryption, and we are having both public and public key algorithms as well as homogeneous algorithms, advanced encryption system. And then networking for routing algorithms like routing information protocol, OSPF, like that we are using that. And artificial intelligence pathfinding to find the path. Example is we are representing traveling salesman problem. So in conclusion, algorithm are the foundation of computing and it play a crucial role in solving problems efficiently, right? So the best approach for given problems to solve the given problem is algorithm. Thank you.